Hi guys, here's my take on free response question number 2. So you're given a variety of summary statistics for rainfall totals in Los Angeles over the course of 117 years. So the first part of the question is to describe a procedure that uses these values to determine whether there are outliers. At this point in our course, the simplest way to do this would be to use the Iqr criteria that we've described in the past. So literally in part A, you don't have to do any of the calculations, you just have to do the description of the calculation. So you would find the Iqr by subtracting Q1 from Q3. Observations that are more than 1.5 of those IQRs above Q3 or below Q1 are then unusual enough to be outliers. So you could describe this by actually showing the calculation in terms you could write Q3 plus 1.5 times the IQR. I just went ahead and described it in words because I'm going to show those calculations with the actual numbers in part B. There's a good reason why you read all 3 parts of the question, A, B, and C, before you bother to actually answer any of the pieces of the question. It is very typical for students to actually do the work that I have in part B up here in part A, and so students end up drawing arrows. There's no reason to do that. If you've read all 3 parts of the question, then you'll know what to write in which spaces. So are there any outliers? You should absolutely say yes. And then here are the calculations. It's important that whatever procedure you describe in part A, you do and use exactly that procedure here in part B. So here is Q3 plus 1.5 times the IQR. That gives you 33.605. I've often called that the upper cutoff. 9.680, that's Q1, minus 1.5 IQRs. That's negative 4.675. So are there outliers? Yes, because if you look at the summary statistics, the maximum is 38.180. The maximum represents a specific value of rainfall in this data set, and it certainly exceeds the 33.605. So you need to say that and make that comparison. Since the max exceeds the 33.605, the data contain at least one outlier. The maximum itself is an outlier. There may very well be more outliers. We just don't know how many more there may be. So there aren't any outliers in the other direction. We can't have a negative amount of rainfall. So looking at part C then, there are a couple of ways to answer this based on what we've studied in class. So in part C, the notion here, only 10 inches of rainfall, is implying that 10 is an unusually small amount of rainfall. That's what my first sentence says. So, but that's really misleading, and there are a couple of ways to think about this. So that 10 inches is in between Q1 and the median. So notice, Q1 is 9.68. The median is 13.07. So 10 is in between those values. It lies within the second quarter of the data. That means that the first quarter of the data between the minimum and Q1, that's 25% of the data. At the very least, that 25% of the data, those years have rainfall that is less than 10. So that's what I am describing here. This means that over 25% of the rainfall totals from the min to Q1 are even less than 10 inches. So in that sense, 10 inches really isn't that unusual. At least 25% of the rainfall totals are even more extreme in that they are even less than 10 inches. That doesn't really make 10 inches that unusually small. So another way to think about this, you could also think about this in terms of standard deviations. So you did not have to write both of these answers. Another way to think about this, typical rainfall totals are within one standard deviation of the mean. So understand, here is the mean, 14.941. So the standard deviation is 6.747 inches of rainfall. So if we start at the mean and add 6.747 inches, or start at the mean and subtract 6.747 inches. That gives us, if you will, a range of what is typical. That's 8.2 inches to 21.7 inches, and the 10 inches falls within that span. In terms of the standard deviation, 10 is really not that unusual. It is within the range of what I would consider, quote, typical values. So I hope this has been helpful.